Hi, so today I'm going to explain the learning target 8A, drawing and explaining the timing diagrams for flip-flops. So first I will going to explain the timing diagrams of negative edge trigger JK flip-flop with asynchronous inputs. The flip-flop updates its output only at the following edge of the clock, which is shown by the downward arrows. Also Q starts in the set state, so the initial value of Q will be 1. Q will be 1. Now I will go step by step through each falling stage. So at the first falling stage, J is 0, K is 1. This corresponds to the reset condition. So Q changes from 1 to 0. At the second falling stage, J is 1, K is 1. This is the toggle condition. So Q changes to the opposite of its previous value. Since Q was 0, it becomes 1. At the third falling stage, J is 1, K is 0, that is set condition. Q remains 1. At the fourth falling stage, J is still 1, K is still 0. So this is again the set condition, Q stays 1. Now the pre-input goes low. Since pre is an asynchronous input, it overrides the clock and the force Q to 1 immediately without waiting for the clock. So CLR means the high throughout the diagram, so it's inactive. So we will take the Q 1. And now at the final falling stage, J is 0, K is 0, this is no change. So no reset, therefore Q keeps its previous value, thus no change. This shows that the output depends on the both inputs and the previous state and only changes at the falling edge unless override by a synchronized input. And the Q bar will be always opposite of the Q, like this. So this is the pre, because of the asynchronous input it goes 1, and we have to keep looking for these points. So now this is toggle set. This is no change. This is where pre-active and the set is no change. So now we will gonna do the characteristic table. So for the characteristic table, we're gonna put J, K, clock edge, QT plus 1, and the more. So this table also applies to negative trigger JK flip-flop. So all happens only at the following clock edge. When J is 0, K is 0, clock will be upside down. So when J is 0, K is 0, the mode is no change. And it will gonna state the same, the QT. So the important thing is QT means the output stays same and q dash t means the output becomes the opposite. Okay, so when j is 0, k is 0, clock is commencement, so there is no change more, so qt. And when j is 0, k is 1 at the following stage, this mode is reset. Yeah, you can see, so this mode is reset, the force output to 0 regardless of the previous value, so 0. And when j is 1, k is 0, this is the set port, like a set condition, so it remains 1. And when finally it forces the output 1, and when j is 1, k is 1, clock is upside down, this mode is toggle, so it changes. So that means the next output becomes the opposite of the current output, written as qt plus 1 equals qt dash. So the overall JK flip-flop updates only at the following clock edge. And asynchronous input like pre can override the clock and directly control the output. Or I can write it as qt bar. I can write it as qt bar. It will be good. Yeah, the opposite of qt. So this timing diagram matches the behavior described in the characteristic table. I think that's it from my side. I hope I didn't make any mistake. So thank you.